Okay, this is Polynomial Operations Part 1. If you were absent on September 4th or 5th, this is for you. Or maybe you just want to see this again. Um, so this warm-up is just to make sure that you know what like terms are. So like terms, those are going to be terms that have the same variable raised to the same power. So for number 1, for example, the like term for 4x would have to be another term that has x to the first power. And so that would be this one. And then constants are like terms as well. So those numbers without variables, we call those constants. So those would be like terms too. So the -10 and the +1 are like terms. So I'm putting circles around the first set of like terms I see, squares around the second set of like terms I see, and if there's a third set, I'll put triangles. So for number 2, let's see. I see we have an x squared term right here, and then here's another one, -x squared. So those are like terms. They both have x to the second power. All right, 3x and 12x will be like terms since they both have x to the first power. And then again, our constants will be like terms, these numbers without variables, without an x attached. So -3 and +1. So I put triangles around that last set. Okay, for number 3, let's see. We have x to the third power. That's going to have a like term with this one, 5x to the third power. And then I see constants. We have -2 and +10. And then this -x squared, it doesn't have a like term. It's just kind of by itself. So I won't put anything around that one. Okay, and then for 4, we could try to find some like terms, but you'll notice this is x to the third power. This is x to the second power. This is technically x to the first power. And then we have a constant at the end. So there are no like terms. So I'm just going to leave everything blank there. And the point of finding these like terms is that eventually we're going to be able to simplify expressions by combining like terms. So we'll be able to add or subtract those like terms. But let's talk about what a polynomial is and the vocabulary associated with it. So poly, we're going to say, means many. So you may know words with the word poly in front, like polygon, that's a shape with multiple sides, many sides, or polytheism, that means many gods. So it means many. And then nomial, sometimes it means name. In this case, it's going to mean terms. So we know polynomial means many terms. And so this official little definition I'm going to put here, we're going to say a polynomial is an expression with at least 2 terms. So every example up here, those are all polynomials. Everything we work with here is going to be a polynomial. And by expression, if you're confused about this word expression, it's like an equation with no equal sign. That's all an expression is. So you can kind of think of it like an equation, but there's no equal sign. Okay, so the next thing we talk about, a lot of vocabulary here in this part, is the degree of a polynomial. So when we say degree of a polynomial, what I really mean is it's the highest exponent in an expression. And so that's how we classify polynomials. So if you look at this example down here, if I ask, okay, what is the degree of the polynomial? And that's what this first question asks. What is the degree of the polynomial? I just have to find my largest exponent, which is a 3 in this case. So I would call this a third degree polynomial. If the largest exponent were 8, I would call this an 8th degree polynomial. It's just a way for us to classify these. Okay? So the next part says, when a polynomial is written with terms in order from largest degree, so largest exponent, down to the smallest one, we call this standard form. Standard form. So looking at this example, you can see our exponents go 3, 2. Technically, that's to the first power. And then we have our constant. So we would say, yes, this is standard form. It starts with the largest exponent, works all the way down to the constant. And something about this constant, you can kind of, and you don't have to know this is kind of extra information here, but really there's always our variable to the 0 power attached to every constant. So it really does go 3, 2, 1, 0. And I know that this is here because anything to the 0 power is always just equal to 1. So it doesn't change the 15 at all by multiplying by 1. So you can kind of think of, that's why the constants come last, I guess, if you're wondering about that. Okay, next part. When written in standard form like this, the coefficient, that is the number out in front of the variable, of the first term is called the leading coefficient. Leading coefficient. So in this case, our leading coefficient, we have to find the term with the largest exponent, so that's 5x to the third, and we just want the coefficients, we just want that 5. So that's our leading coefficient. It's always going to be the coefficient that's attached to that term with the largest exponent. And if it's already in standard form, then we know it's just going to be that coefficient that's right out front in the lead. So that's where that comes from. Okay, so let's look at some examples here. This is the real stuff that you'll see on a quiz or a test. So it says, simplify the following polynomials and write each answer in standard form with, largest exponent down to our smallest exponent. So for number 1, I know we're going to be combining like terms for all of these. So I'm going to start by finding like terms. So that's going to be 6x and negative 2x. And I was doing the circles and the squares and the triangles and the warm-up, but really when I get to the problems, I like to do underlines and then squigglies for my next set. It just keeps it more organized. So I know my constants, negative 10 and positive 14, are also like terms. So we can combine those. So we'll say, okay, 6x minus 2x, that's going to get us 4x. And the 4 comes from just doing 6 minus 2. I'm really just combining those coefficients. And then here we have negative 10 plus 14. That gives us a positive 4. All right, and notice when we're just adding and subtracting these terms, the exponents don't change, right? They started as x to the first power, and in our answer, it's still x to the first power. The exponents only change when we're multiplying or dividing. But here we're just adding and subtracting. So you're always going to get the same exponent in your answer. Okay, for number 2, I'm going to start by finding my like terms. So we know the x squareds, 4x squared, and negative x squared. Those are like terms. And really this is negative 1x squared, if you want to put that 1 in there so you don't forget. And then we have 3x and 6x. So I'll combine these. 4x squared minus 1x squared, that'll get us 3x squared. And the 3 comes from just 4 minus 1. Right? And then 3x plus 6x, that's 9x. And the 9 comes from 3 plus 6. And that's it. Notice my exponents didn't change. I started with second power, and then I have it here. And we have first powers, still have it here. Okay, let's look at number 3. So I'm going to start by finding my like terms. So my x squareds I see first. I have negative 2x squared and positive 4x squared. And then it looks like there aren't any other like terms. I can't combine an x with a constant. That just doesn't work. So let's combine these. Negative 2x squared plus positive 4x squared. That'll get us a positive 2x squared. That's because negative 2 plus 4 gives us this positive 2. And then since I can't combine these two, I'm just going to have to bring them down. So I'll bring down my plus x, and then I'll bring down my plus 6. That's all we can do there. Okay, moving on to number 4. So you may notice on number 4 we have parentheses. And so when you see parentheses in math, you may think multiplication, distribution. In this case, it's like we have ones out in front here that we could distribute. You don't see a number, we always know there's a 1 there. But distributing a positive 1 to everything, well, that doesn't change anything. Multiplying by 1, a positive 1 that is, does not change anything. So really, if you just see a bare plus sign between parentheses, it's like we can just drop the parentheses. So I'm going to rewrite this without the parentheses. 3x squared plus x squared minus 5x. All I did was remove the parentheses here. And now we can just combine like terms. So 3x squared plus, what is essentially 1x squared. That'll give us 4x squared. And then here we have 1x minus 5x. Well, 1 minus 5 is negative 4. And then I'll attach my x. So if there's just that bare plus sign without any numbers, we can just drop the parentheses. Kind of just trying to confuse you there. All right, let's look at number 5. So here we have a minus sign in the middle, and this does change stuff because this is like we're distributing a negative 1. And so if we have to multiply everything behind it by negative 1, that's going to change those signs. And when we are distributing, we only do it to everything behind, right? So I'm not multiplying anything up front by that negative 1. It's just the stuff behind it. Actually, nothing is going to change here. It's like we're distributing a positive 1. So that doesn't change anything up here. So I'm going to rewrite this first expression exactly how we see it. 4x squared plus 5x plus 12. And now I'll go ahead and distribute. So negative 1 times x squared, that's negative x squared. And negative 1 times 3x, that's negative 3x. As you can see, the signs just changed here. These were positive, and now they're negative. That's what happens if we multiply by negative 1. So now we can clean this up by combining like terms. So 4x squared minus 1x squared. Remember, there's that 1 there. I don't have to write it every time. 4x squared minus 1x squared, that's 3x squared. I can combine my x's, so that's 5x minus 3x. I know that's 2x. And then this 12, this constant, doesn't have a like term, so I'll have to just bring that right down. And that is our answer. All right, for number 6, again, we're distributing what is a -1, really, to everything behind, every term in this expression. The first expression doesn't change, so I'm just going to write that down here, x squared minus 9. But now we have to do -1 times 4x squared. So that's -4x squared. Then we have -1 times -9. Well, a negative times a negative, that gives us a +9. And then we can just clean this up. We have 1x squared minus 4x squared. Remember, there's really a 1 out here. Well, that's -3x squared. And then -9 plus 9, that's just 0. Those just cancel right out. So I could put +0, but I don't really have to. Adding 0 doesn't change anything, so I'm going to leave it out. I'm just going to put -3x squared. Okay, let's go down to 7. So here I do have a plus sign in between, but it's not just a bare plus sign. There's this 3 here. So I have to take this 3 and distribute it to everything behind. All right. First expression also has a 2 that I'm going to have to distribute. Okay, so 2 times x, that gives us 2x. 2 times 5, that gives us 10. And then I'll come over here. We have 3 times 2x, that's positive 6x. And 3 times -6, that's -18. So I just distributed twice here. And then I'll combine like terms. So 2x plus 6x, that's 8x. The 8 comes from 2 plus 6. Then we have positive 10 minus 18. 10 minus 18, that's -8. All right, for number 8, we have to distribute this -4 before we combine any like terms or anything like that. So I'm going to distribute it to every term behind it. First expression does not change, so I'll just rewrite that. 10x squared minus 7x. But now we have to do -4 times 3x squared. It's -12x squared. And then -4 times x, that's -4x. And then we can combine like terms. So I got 10x squared minus 12x squared. Well, 10 minus 12, that's -2. And then I'll attach my x squared. And then we have -7x minus 4x. Well, -7 minus 4, that's -11. And then I'll attach my x. Feel free to pause this video at any time if you want to try the next one ahead here. So for number 9, we have to distribute this 2 to everything in this expression. This part will not change though, because we're just really distributing a +1 to everything. But for here, I'm going to do 2 times 6x squared. So that's 12x squared. And we have 2 times 7x, that's positive 14x. 2 times -1, that's -2. And now I can just bring this part right down without the parentheses, plus x plus 1. So after we distribute, that's when we can drop the parentheses. Okay, and then we can just combine like terms. So I don't see any other 12x squareds, or any other x squareds rather, so I'm just going to bring this term down. We have a couple terms with an x, so I can do 14x plus 1x. That's going to be 15x. And again, I could put the 1 here. I don't have to every time, but if you need reminding, you can put that 1 in there. And then we have negative 2 plus 1. That'll be negative 1. There we go. Okay, so let's look at some more challenging examples on the back side. So for number 10, I'm going to have to distribute this negative 2 to every term in that expression. The first expression does not change at all, so I'm going to bring that right down. I'll bring down x squared minus 5x cubed plus 8x. But now we have to distribute this negative 2. So negative 2 times negative x to the third power. Well, negative times a negative is a positive. That'll be 2x to the third power. Negative 2 times 4x, that's negative 8x. And then negative 2 times negative 3x squared, that's positive 6x squared. So make sure all of your signs are correct. There's a lot of places here to make a mistake. So I'm going to combine like terms, and I want this all in standard form. So I'm going to start with my highest exponent, the x to the third power terms. So let's see, we have negative x cubed, x to the third power, and positive 2x cubed. So negative 5 plus 2, that's negative 3x to the third power. And now I'll look at my x to the second term. So I have 1x squared plus 6x squared, that's 7x squared. And now I'll deal with my x terms. So I have positive 8x minus 8x. So those just cancel right out. Those are just 0. I don't have to put a plus 0 because that really doesn't change anything. So I'll just put this as my answer. Okay, number 11, we have to multiply. We have to distribute what is a negative 1 here to everything behind it in this expression. Our first expression doesn't change at all, so I can rewrite that here. We have 8x to the 5th minus 9x squared plus 8x. Now I have to distribute this negative 1. So negative 1 times 4x squared, that's negative 4x squared. And negative 1 times 8x, that's negative 8x. Negative 1 times positive 2 is negative 2. So from here we can combine like terms. I'm going to start with my highest exponent I see, which is this 8x to the 5th. It doesn't have any like terms, so I'm just going to bring that right down. Okay, and sometimes I like to cross them off as I go so I know I don't reuse anything. So let's see, the next highest exponent is a 2. So I have negative 9x squared minus 4x squared. That gives us negative 13x squared. So I use those, they're underlined. Now I'll deal with my x terms. I have positive 8x minus 8x. Well, that's just 0, those cancel, so I won't put anything there. And then I have this negative 2 that I can bring on down. Doesn't have a like term, so I'll just bring it right down. And there's our answer in standard form. Okay, look at number 12. We're going to have to distribute twice. We're going to have to take this negative 3 and distribute to everything behind it. And then this positive 2 we'll have to distribute to everything behind it. So be careful with signs here. We have negative 3 times positive 4x squared. That's negative 12x squared. Negative 3 times positive 2x, that's negative 6x. Negative 3 times negative 8, that's positive 24. Now I'll have to distribute this positive 2 to everything. So 2 times negative 3x squared, that's negative 6x squared. And 2 times negative 7x, that's negative 14x. 2 times a positive 1, that's positive 2. And so now we'll combine like terms, trying to keep this all in standard form. So let me find my highest exponent. It looks like the 2's. So negative 12x squared minus 6x squared, that's negative 18x squared. And then I have negative 6x minus 14x, that's negative 20x. And then 24 plus 2, that's a positive 26. Okay, for number 13, it looks like we have to distribute this positive 4 to everything in that expression, and then a negative 1 to everything in this expression. Remember, that's going to change the sign on everything back here. So 4 times 5x cubed, that's 20x cubed. 4 times negative 2x to the 5th, that's negative 8x to the 5th. 4 times 3x, that's 12x. And now we'll distribute this negative 1. So negative 1 times 18x cubed, that's negative 18x cubed. Negative 1 times 8x to the 5th, that's negative 8x to the 5th. And negative 1 times a negative 3x, that makes it a positive 3x. And then we can just combine like terms. I'm going to start with my 5th powers. So negative 8x to the 5th minus 8x to the 5th, that's negative 16x to the 5th. They don't cancel out because one is negative and the other is also negative. One would have to be positive if they were going to cancel out. So we have 20x cubed minus 18x cubed. Well, 20 minus 18, that's positive 2x cubed. And then we have 12x plus 3x. That's positive 15x. And that's it. So 10 through 13 I would consider challenging adding and subtracting problems. Okay, let's go on to a word problem here with number 14. So it says a rectangle has a length of 5x plus 3 and a width of x plus 1. We want to write an expression that represents the perimeter. Okay, so I'm going to start by drawing a rectangle. I'm going to label my length as 5x plus 3. It says it right here. And my width, they say, is x plus 1, so I'll label that. And so we want an expression for perimeter. Remember, perimeter is just the length around a figure, the distance around a figure. And we're not going to get a nice, cute number like the perimeter is 15. No, it's going to involve x because our length and our width have x involved. So when I asked this in class, some students said, okay, well, we just have to do 5x plus 3 plus x plus 1. That's not quite right. That's just half the story. We still have to add this side and this side. So I know if this length is 5x plus 3, down here this also has to be 5x plus 3. And if this width right here is x plus 1, you know, if this is a rectangle, over here it's also x plus 1. So it looks like we have 2 lengths and 2 widths, right? And that's really where we get this classic perimeter equation where it says perimeter is equal to 2 times our length plus 2 times our width. And hopefully this isn't something you have to memorize. Hopefully that just makes sense to you. You could go through and do, okay, 5x plus 3 plus x plus 1 plus 5x plus 3 plus x plus 1. And you would have this long expression written out, but at the end of the day, it's the same thing. So I'm going to fill in my length and width with what they provide us. So this will be 2 times 5x plus 3 plus 2 times x plus 1. And now we're going to have to distribute these 2's. So I'm going to distribute this 2 to everything. And then this 2 to everything. So we'll get 2 times 5x, that's 10x. 2 times 3, 6. Plus 2 times x, that's 2x. And 2 times 1, that's plus 2. And then we can just clean this up by combining like terms. So 10x plus 2x is 12x. And then 6 plus 2 gives us a plus 8. So 12x plus 8 is that perimeter. That represents the perimeter. Okay, so number 15 is a really similar question. It says a rectangle has a length of 3x minus 2 and a width of 6x plus 5. Again, we want to write an expression that represents the perimeter. So I would always draw a picture. My length is 3x minus 2. My width is 6x plus 5. Well, now that we understand how perimeter works, I'm just going to go back to our formula here. I'm going to say this is going to be equal to 2 times our length plus 2 times our width. And so again, we're going to have to distribute these 2's inside the expressions, inside the parentheses. So that's going to give us 2 times 3x, that's 6x. 2 times negative 2, that's minus 4. Plus 2 times 6x, that's 12x. And 2 times 5, that's 10. So 6x plus 12x, that gives us 18x. And negative 4 plus 10, that gives us a positive 6. So that represents perimeter for this problem.